Welcome back to Getting Started with CellEngine, a series of videos designed to take you through CellEngine's features step by step so you have the tools you need to analyze your own cytometry data. This is the first of two videos that will be focused on making figures. If you don't have a CellEngine account yet, you can sign up for a free trial at cellengine.com and follow along with the series. Previous videos have covered experimental setup, adding metadata to your samples, and gating. You'll find links to those in the description below. Today, we're going to do an overview of the illustration page where figures can be created and arranged. We'll make flow plots, including histograms and dot plots, and look at some of the features you can use to organize components and batch illustrations to automatically generate additional pages of figures. Then we'll look at pivot tables, which can automatically generate grids of flow plots, and discuss how they can be organized for a variety of purposes. Let's switch over to CellEngine. First, we'll begin by making an illustration page. On the navigation bar to the left, click New Illustration, which will create a new page, and the cursor will be auto-focused on the name. I'm just going to rename this to Flow Plots. You can make as many illustrations as you want in an experiment. You can either create new illustrations like we just did, or click on the duplicate icon in the upper right to create a copy. Illustrations can also be imported from existing experiments. The process for this is discussed more in detail in the advanced gating video. Each illustration page can contain multiple components. These are all arranged in the top bar above the main window. The components include elements like arrows and text boxes, but most relevant to our discussion are going to be the plot types, which are arranged on the right-hand side. If your browser window is narrow and doesn't show all the icons, you may see three dots on the far right-hand side. Click those to get access to other icons. To put down a flow plot, click on the icon in the top bar. In this case, the icon will look like a dot plot. Click to place the plot anywhere in the illustration page that you like. You can click and drag to adjust the size of the plot during placement, or adjust it afterwards by dragging the handles on the edges. When you have a plot selected, you'll see options for that plot on the right-hand side. These options are broken into sections, so let's go over them one by one. As we go through them, you'll notice that a lot of the elements are shared with the plot setup on the gating page. For example, the file selector is the same, so we can filter files based on annotations by clicking on the three horizontal lines next to any annotation column, just as we did in the gating video. Clicking on the population drop-down box will show the hierarchy, and the Show and Parent button will appear as you mouse over different populations. This will automatically set the channels to display the gate, just as it did in the gating page. X and Y channels can also be set manually here, or by clicking on the axes in the plot itself on the page. There's also a quick swap option to change the orientation of your plot if helpful. Plot settings are also similar to the gating section, with smoothing and color scale options, and the ability to display dot plots, histograms, and contour plots. By changing the plot type to dot plot, you can also color a plot by a specific channel. This color channel selector will show up under the General section of options once you change the plot type to dot. This setting will be remembered if you change your plot type to something else, so we can change the plot to a contour plot and then go back to a dot plot, and by default the coloring will remain the same. Plots can be further styled by hiding the population name, or in the next section, by changing the gate label. Gate labels by default show the percent of parent, but you can change them to display the gate name, another statistic, or hide them entirely. Axes and Legend lets you style the tick marks and axis labels as well. If you want to only show a subset of events from your population, you can also use subsampling. Subsampling can either show a percentage of total events or an absolute count. If you're trying to compare two plots with vastly different event numbers, for instance, you might want to use an absolute count so it's easier to compare. If you subsample before gating, you'll equalize the number of events in each sample, while if you subsample after gating, you can select a specific number of events. For instance, you could display 1,000 CD8 T cells for each plot. Keep in mind that subsampling only changes the number of events displayed on the plot and doesn't change the underlying statistics. So if we change the gate label to event count, it will still display the actual number of events. This helps reduce the risk of creating misleading plots by accident. CellEngine will pseudo-randomly choose the events that are subsampled. A different seed will be used if you refresh the page or figure. If you'd rather the same cells are selected every time, you can enter a seed, and that way the events that are subsampled will be the same from refresh to refresh. The last section in options has options for exporting figures. This will download a PNG or PDF file with the components that you've selected. In addition to exporting, you can copy paste illustration components into other software programs like PowerPoint or to other illustration pages or even the same illustration page in CellEngine. This is often convenient when creating gating hierarchies or other layouts that have small changes between figures. Multiple figures can be selected simultaneously and modified together in the sidebar as well. For instance, if I wanted to change both of these plots to display the name of the gate on the label, I can select both of them and then make the change in options. Only the options that are shared between the selected components will be displayed. Multiple components can also be treated like one in terms of exporting, copying, resizing, and other behaviors. Let's create a larger layout and talk about some of the other illustration features available. For this example, let's make a small gating hierarchy for one of our samples. I'm going to turn off tick marks on this first plot and make any other style changes that I want, and then I'll copy paste it and make changes from there. The only thing I'll need to do on the copies is select another population, and I'll use show in parent to set the channels automatically. You can also collapse the navigation tab on the left-hand side to give yourself more space to work if you're creating these larger layouts. Now that I've put down a few plots, I'm going to connect them with arrows. You'll notice that when you have an arrow selected, there are a few style options to the right in the top toolbar. Let's change the color of the arrows. I could go back and manually select the components individually by dragging or shift-clicking. CellEngine can also select components for you, which is often helpful on larger or more complex illustrations. To do this automatically, go to Edit. Then you can select based on a shared characteristic or select all components on the page. In this case, we want to select all of the arrows, so I'm going to select the same type, which will select all arrows. Now we can change the color of them all simultaneously in the top bar. These plot positions are a little bit uneven, so let's straighten them up. There are several options that can help with plot alignment. The top bar has options for turning on a background grid, which can be toggled on and off with the grid icon, and also a snap to grid option signified by the magnet icon. This can make it easier to place or align plots relative to the grid. Sometimes a bigger challenge is aligning plots relative to each other, especially if your plots are different sizes. When you select multiple components in an illustration, you can click on Arrange and then align plots by different edges. For example, we could align all top or bottom edges on the same line, or you can choose to align by center or midpoint of the component. I'm going to align all the selected components by the bottom edge for this example. Now that we've created part of a gating strategy for this particular FCS file, what are our options if we wanted to create the same figures but for a different file? We could copy the individual plots and then use the file selector to change the selection. We can also duplicate the entire illustration, but the most efficient way is to use batching. A batched illustration will treat the page you've created as a template and generate additional pages based on the variables that you select. You can use a wide variety of variables, including channels, populations, and annotations. For a simple example, I'm going to set this illustration up to create one gating hierarchy for each file in the experiment. To do this, click on Batched Illustration at the top of the page. This will allow you to select page variables right next to it, which will open up a dialog box. Here we're going to select the variables that we want to batch on. You can use one or multiple variables. For example, we could set up a separate page for each treatment group or for every time point in an experiment or each population, or even combine them so you see every population for every cell line for every treatment group at every time point gets its own page. Since we want one page for each file, I'm going to choose FCS files as the batch variable. For values, we can choose individual files or check the box at the top of the column to select all visible. There's also an all values option, which is a little bit different. Once I choose that, you'll see the values are listed as all values dynamic. This means that the selection of files will dynamically update to select appropriate values as the experiment changes. Here, if I add another 20 files to this experiment tomorrow, the figure will automatically update itself to include those files. This can be extremely useful when you're doing analysis partway through a time course or don't have complete metadata for all of your samples yet. When you're done making selections, click on Close. There's one more thing we'll want to do, which is enable batching on the figures in question. I want to batch all of the plots on this page, so just like before, I'm going to select one flow plot and then use Edit, select Same Type to select all the flow plots on the page. Then I'll check the checkbox Batch next to the variable that you want to batch by. In this case, that's the FCS file name. If you don't want to batch a particular figure, for example, if there's a control file that you'd like to remain constant as a reference in each page, just leave that unchecked. Now we can flip through the batched pages at the bottom of the screen to see our results. Batched illustrations can also automatically update text boxes with variable information. Let's go ahead and add a text box to our illustration using this icon on the top bar. Whenever you've got a text box selected, you can choose the rightmost option to see different variables that can be shown in the text box dynamically, including annotation and illustration information. In this case, let's add treatment information for the sample in question, along with what page we're looking at out of the total number of pages in the batched illustration. If I want to download the entire illustration, I can do so at any time by going to File and then selecting Download PDF. When your illustration is batched, each page of the illustration will be on a different page of the PDF file. In addition to generating plots individually or with batching, you can use pivot tables to generate and arrange grids of flow plots. Let's make a new illustration page and create a simple pivot table. To place a pivot table, click on the icon right next to the flow plot on the top bar. When you first place a pivot table, it will be blank. Pivot tables select matching files automatically based on the variables that you select. We'll go through several different examples of pivot tables, but for our first one, let's generate a table to look at the gate placement of a specific population. I'm going to set rows to populations and then use the Show in Parent button to set the channels automatically for the population that we select. Then for columns, I'm going to set it to show FCS files and use the Select All Dynamic option, which will allow it to automatically update in the future. Many users like to review gate positions with pivot tables because it allows you to scroll through the files quickly and review a lot of positions simultaneously. You can even add additional pivot tables below so that you can look through many plots at the same time. If you ever want to make a change to a gate, you can go directly to the gating page by right-clicking on the plot in question and then choose View and Gating to go to that plot, where you can then make whatever adjustments you need to make. Pivot tables can also be organized by annotation information. This particular experiment has samples that were taken from different donors and then treated with cytokines. This information was added in annotations, so we can use those variables to set up our pivot table. I'm going to set treatment to be the columns and donor to be the rows. If I select all values for those options, we'll be looking at plots of this population for all the samples in the experiment. Sometimes it's helpful to have more grids than we can specify with just rows and columns. For example, you might want to view more than one population in the same pivot table or have more than one time point. In these cases, we can also add additional dimensions to pivot tables. This experiment stained for multiple signaling proteins. We can display all of these in the pivot table by clicking on Add Table, then choosing X or Y channels. In this case, I'll choose X channels so that the changes take place on the X-axis. I'll select all of the channels of interest, so now the plot will have information on these markers for every donor and every treatment. We can continue to use dimensions to expand the pivot table. For example, we're currently only looking at one population, but I could select Add Table again and add another dimension for particular populations of interest. When scrolling through large pivot tables, it can be helpful to have more information about the plot that you're looking at. You can mouse over a plot for more information, or make sure that the pivot table labels are always visible by going to View and turning on sticky labels. Pivot tables can hold thousands of plots and are easily reorganized. If you need to adjust the order of your plots, you can use these arrows to the left and right of the dimensions, and you can change the orientation as well from horizontal to vertical and back. That way, you can set up large grids of flow plots for review and comparison and easily reorganize them on the fly. However, the flexibility of pivot tables can make it challenging to set up at first. Our documentation has a section of examples with specific steps for making several kinds of pivot tables. For the rest of the video, let's take a look at some of the most common use cases for pivot tables. We've already discussed their use for reviewing gate positions. They can also be used to rapidly set up in-by-in plots. Let's make a new illustration for this. I'll select and set down a new pivot table, change the columns to X channels, and then select whichever channel values you'd like to display. For rows, choose Y channels as the name, and then for the channel values, either select them manually or, for convenience, you can choose the same as X channels option, which is what I'll pick. To finalize the pivot table, we'll need to choose what populations and files to display. For this example, I'll just select one population and FCS file from the general section of options, but keep in mind that you could add additional dimensions or set up batching, just as we did with earlier examples. Pivot tables can also be colored by channel. If you only want to color by a single channel, you can set this up the same way we did for flow plots earlier in the video, by setting the plot type to dot and then selecting a channel for the color. However, it can be helpful to set up grids of plots that are colored by different channels, and for this we can use coloring by channel as a dimension of the table itself. This is especially useful when you're reviewing results of algorithms like a t-SNE or a UMAP. We'll be talking about how to run algorithms in a later video, but for now, know that you can run and visualize the results of algorithms within CellEngine itself. Here's an experiment where a t-SNE has been run. I'm going to start by putting down our pivot table. Then I'll change the rows to populations. For this example, let's just look at the ungated events so that we can see the spread of the data. I'm going to manually set the channels to display the t-SNE results for the different channels. For this example, let's select a single FCS file to display, which can be done from the file selector. Finally, let's set the column dimension to color channel. Now we can add as many values as we want to the color channel option, and they will be displayed as part of the grid. Pivot tables can also be used to overlay two or more plots. If a dimension can be overlaid, you'll see the overlay checkbox underneath the values for that dimension. For an example, let's make a copy of the pivot table that we just created. Instead of looking at just the ungated population, let's change the population selection to some particular cell types. Now we have a pivot table showing the populations individually. Let's click on the overlay option underneath the population values. CellEngine will automatically apply colors to the overlay and provide a legend to make it easier to identify different populations. The same approach can be used to overlay histograms. We'll return to one of our earlier examples where cytokines were used to stimulate samples. We set up a pivot table with X channels for the signaling markers. Let's change the plot type to histogram now. It might also be interesting to compare signaling across cell types, so I'm going to add one more table for populations and select a few groups of interest. Now we'll choose what we want to overlay. Let's start by overlaying the cytokine conditions. If you'd prefer to see the responses of different cell types, just click Overlay underneath populations instead. Histograms are by default displayed slightly staggered. If you want more or less spread between your histograms, adjust the pitch, which you'll see next to Overlay in the options. Under plot settings, you'll also find a few more styling choices. I'm going to turn up plot smoothing a little bit and then increase the fill opacity so that all of the histograms are easier to see. You can also adjust the line thickness for the edge of the histogram. One other option you'll find here is the color palette. CellEngine includes several default options, or you can customize your own choices. We'll be talking in depth about color palette customization in the next video when we discuss grouped analysis. That discussion will also apply to overlay pivot tables, so if you're interested in the specifics, check out the next video. This concludes the introduction to illustrations and should set you up to begin making flow plots individually and with pivot tables. Next time, we'll talk about plots that group files together: bar graphs, box plots, line charts, dose response curves, and heat maps. We'll talk more about picking exactly the subsets of files you want for a particular figure and how to manually or automatically assign colors to different variables. In the meantime, if you have any questions, feel free to contact us anytime at support@cellengine.com.